Hello, 30-1s. In this video, we're going to look at using the laws of logarithms for simplifying and expanding. What I want you to always do when you're working with logarithms is make sure that you've got your formula sheet in front of you. So what we're going to look at today is we're going to look at using these laws right here. Now, going this direction, this would be expanding. We have more than one logarithm. And going the other direction, this way, that would be your simplification. It depends on the question what you'll be asked to do, but more often than not, we prefer to simplify than to expand. The other two laws here, we typically use when we're solving logarithms equations. We'll use those in a different video. Okay, let's go look at a question. Here's a very, very basic question that we'll see. Simplify the following. Okay, well, all this tells me to do then is when it says simplify, is it says, okay, let's write this as a single log. No big deal. So to simplify, I say, okay, there's an adding and an adding. Well, that tells me my logarithms then will then be, the arguments of my logarithms, I should say, will then be multiplied together. But before we do that, this is really important, friends. You see these coefficients right here. If I scroll back up and look at my laws of logarithms, I don't see a coefficient here or here. So what's really, really important, put a big star beside this. If I want to simplify, I must get rid of my coefficient and make it my exponent first. Just like that. So remove my coefficient, make it an exponent first. Now I can say to myself, the bases are all the same. Now I can multiply my arguments together. And I'm going to rewrite z. Something to the exponent of a half is actually the square root of z. So there it is. So this is incredibly important, friends. If there's a coefficient and you're simplifying, that coefficient must become an exponent before simplification. That's it. And if you look again at your formula sheet, there is no coefficient. Well, there's a coefficient of 1. So if the coefficient's anything other than 1, you need to make an exponent first. Simple as that. Okay, let's try another one. Okay, this one says still simplify, but this time I notice there's a minus sign in between. So what that tells me we'll do is we'll divide our arguments just like this. And then what I want to say to myself, is there anything else I can do to simplify? Well, sure, I can start factoring these things. This is x minus 4, x plus 4, x minus 4, x plus 2. And okay, I got to know something's going right here because look at these two factors here will divide. Oops, I crossed off the wrong one, didn't I? I got excited by the division. These two will divide. That looks a little better. And what do we have left? We've got log base 10 of x plus 4 over x plus 2. There it is. Okay, so there's simplification, which is, in terms of math and what we're trying to do, is usually what we want to do. But on occasion, you're going to get a question like this, where it's going to ask us to expand. Okay, no big deal. What I say to myself is when something's being multiplied together, that means when I expand it, they will be added. Just like that. And if I'm being divided, that means there's a subtraction in between. There it is. That's the expansion. Now, we could take this one step further if we wanted to, and I could take that exponent and make it a coefficient. There it is. All right, there's the expansion. Easy peasy. Then what we get into are questions like the next one. which to me, I dub these as puzzle questions. That's what they are. They're just testing, can we use the laws of logarithms? Are we comfortable with them? So here's what this says. It says, for some reason, if log 6 is equal to x and log 7 is equal to y, what is log 144 in terms of x and y? Okay, there's more than one way to approach these, friends, but here's how I'm going to approach this thing. Is I'm going to do this. The first thing I'm going to note is that this thing here shouldn't be a 7, it should be a 2. Okay, the second thing I'm going to note is this, is I'm going to try to break 144 up into 6 and 2s. So I call these two things here my hints. So watch what I'm going to do. I'm going to say log 144. Well, log 144 is actually, I'm going to divide 144 by 6. And I'm just going to show it off to the side here. I'm going to do it old school. I don't have a calculator. Oh, look at that. Okay, so log 144 is really 6 times 24. Okay, why did he do that? What's that going to help me with? Well, I see that 6, right? That's that 6 there. And then I'm going to say, okay, well, look at 24. I can get a 6 out of that. That's 6 times 4. Ah, okay, I see a couple of my arguments from my hints. And then I'm going to say, look at this. 4 is really 2 times 2, isn't it? Okie dokie. Well, now I'm getting there because those were both the given statements. Now all I'm going to do is expand this, just like this. Well, what do I know now? Well, way back up here in the question, what it tells me is if log 6 is equal to x. Well, guess what? There's log 6. That's x. Log 6 is x. Log 2 is y. Log 2 is y. So this is 2x plus 2y. So again, what I was attempting here was I was attempting to take what I'm asked to change the form of, and I wanted to get my hints into it. And how did I get my hints into it? I divided. And by doing that division, and then I sort of keep repeating the division, then I can expand and I can get my hints in. That's it, friends. There is your using your laws of logarithms to simplify, expand, and what I call puzzle questions.